Hello again, welcome to 10.3, charge in electric currents. So this is charge in electric currents. Last video we were doing series and parallel circuits, and so we should understand that concept. And so when we're talking about current, what we're actually talking about is the transfer of energy. And the energy comes about because charge is being moved around. And so the current is made up of charge, which carries energy, which is then converted. So something like a light globe, if there's no current, there's no charge going through it, and therefore you don't get any light. If you let the current go through, which means lots of charges are moving through the light globe, i.e. lots of electrons, you get light. Okay, so current is the flow of charged particles, mostly electrons, rarely ions. We measure current by an ammeter or a multimeter, which has an ammeter built into it, but traditionally the symbol is A with a circle in it. And the size of the current tells us how much charge is flowing in a second, because current is measured per second. And whereas charge is measured in coulombs with a capital C as its unit, current is measured in amperes, or amps, which is capital A as its symbol. 1 amp equals 1 coulomb per second. And we can use the equation charge equals current times time. Q equals I, where Q is charge. The C is not charge, the C is the unit for charge. Q is charge, equals I, that's a capital I, times by T. Again, I is for current, the A is the unit. And so here's a circuit, there's our battery, there's our ammeter. An ammeter only measures the current that goes through it. And so if you want to measure the whole current in the circuit, you would put it here, or here, or here, anywhere here. You don't really have a choice, because this is a series circuit, every part of the circuit gets the same current. So the ammeter position doesn't matter. But you're getting 2 amps. So the current is 2 amps, capital A. In each second, 2 coulombs of charge passes through any point in the circuit. So in 10 seconds, you would get 20 coulombs of charge passing through each part of the circuit. Does that make sense? Now this is our ions. So here we have an electrolyte. Remember the term electrolyte? That's a solution that contains ions. We have a battery, and we have a potential difference here. So electrons are flowing in this bit, but then electrons are jumping across onto molecules or ions, and the ions are moving left or right. But the same principle applies. In this case, the current is half an amp each second. There's half a coulomb, and therefore in 60 seconds it would be 60 times by half an amp, which equals 30 coulombs. Okay. Now we have this equation on your information book sheet or booklet. I equals Q on T, which is just a rearrangement of the little one I mentioned before. And I represents current in amps, T is time in seconds, and Q is charge in coulombs. Now just a little sideline here. The electron, in most circuits it's electrons carrying the charge and the electrical energy through the circuit. That's pretty much a given. Now each electron has this amount of charge, which is 1.6 times by 10 to the minus 19 coulombs, which is a very small number, but there's a lot of electrons. So it carries a little bit, but there's a lot of them flowing, and that's why you can get huge currents. Therefore, a current of 1 amp is being carried by, remember that 1 amp is 1 coulomb per second, so if we divide the 1 coulomb by the charge of 1 electron, this gives us the number of electrons that is carrying that charge, or that current. And it's 6.25 times by 10 to the 18. So we could jump this decimal place 18 times, adding a 0 each time, and that's how many electrons are flowing. Note, ions can do this as well, but the charge of the ion would be different, perhaps. Now, I'm going to be giving you a handout in class, and it's going to be on your OneNote on electric current. These are the answers for the questions, but don't worry about that because they'll be posted on the OneNote as well. Okay, so in the next video we're actually going to look at the electron transfer that occurs in electric circuits.